So this is a screencast just to recap spirometry as part of the pathology recognition series for the PRP module. So we've talked a little bit about lung volumes and what they mean, and spirometry is a way of measuring those lung volumes and pulmonary function tests, and they can tell us quite a lot about someone's lung function just from basic lung volumes, but also dynamic lung volumes and also airflow. So it gives us a better picture of not only the amount of air entering or leaving the lungs, but how the lungs and the airways are influencing that airflow and the volumes that we're achieving. And so it's a way of evaluating the sort of mechanical function of the lungs. And what we do is we measure individuals' lung functions, and I'll go on to that in a moment. But there's been a lot of work done quite a while ago now, based on normal values, and so there is a way of predicting what an individual should be able to achieve with their lung volume, and that tends to be based on gender, height and age, and we know that these factors influence what we expect someone to achieve. Okay. So, in terms of what's taken, the measurements that we take as basic spirometry that we're going to talk about in more detail as part of the pathology recognition series are three very basic measurements. The first one is known as FEV1, and that is the forced expiratory volume in 1 second. So basically, that's the amount of air that you can forcibly exhale in that first second of a maximal breath out. Okay, so it's the amount of air that you can get out of your lungs as quickly as you possibly can. Now, in a normal subject, you would expect that about 80% of that total lung volume can be exhaled in that first second, and that's because we're using our internal intercostal muscles, we're using our abdominal muscles, and we are forcibly pushing the air out of our lungs. And we know that our airways are nice and compliant. We've got the elastic recoil of the alveoli. Our airways aren't obstructed, and therefore there's no obstruction to flow. So normally 80% of that total lung volume that you could exhale is expelled in that first second. And therefore the FEV1 measures the amount of air that is expelled in the first second. We also measure the total amount of air that you can exhale. So as part of the basic spirometry, we would ask someone to take the biggest breath in possible, and then breathe out as fast and as hard as they can for as long as they can. And the FVC, the forced vital capacity, equates to the total amount of air that they can forcibly exhale during that breath out. And as I say, we ask someone to breathe out for as long as they possibly can. So the point at which they can't breathe out anymore is the total amount of air they've been able to exhale, and that is classed as the forced vital capacity. The calculation then that we make is looking at both of those two volumes. So we look at the FEV1, so the amount exhaled in that first second, divided by the total amount. And as I say, that should be about 80% of the total value. So this is kind of depicted on this curve here. So what happens is you get someone to take a big breath in, they hold the breath in, and then they breathe out as fast as they can, as hard as they can, and that's when you start measuring. So they breathe out very, 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 very quickly, and that's the first second they get here. Okay, so that equates to your FEV1. So for here, it's about 4 litres. And they continue to breathe out. They keep going until they can't breathe out anymore. And as you can see, this plateaus off quite quickly. And so a normal spirometry curve would be represented in that way, where you have a very sharp increase in volume in that first second, and then it starts to just peter out.